In this video, guys, I really want to just cover the relationship between f, f prime, and f double prime. And I think there's a lot of confusion here, but it's really simple. You just got to take it back to what you do know. So f, a lot of times they're asking questions about f. So we could use f prime and f double prime to tell us quite a bit about f. So if you have f prime, let me move this graph a little more. We'll talk about the graph in a little bit. But if you have f prime, well, what does f prime tell you about f? Well, if f prime is positive, then that tells us that f is increasing. So if something's derivative is positive, then that means that its function, the original function, would be increasing. So if they're asking you when is f increasing, then look at its derivative. If they want to know when is f prime increasing, well, look at its derivative, and we're going to talk about that in a little bit. They want to know when is g decreasing or increasing. Look at g prime. If they want to know when your position is increasing or decreasing, look at velocity, its derivative. So we look at the first derivative to tell us if a function is increasing or decreasing. Similarly, just to write this out, if f prime is less than 0, meaning it's negative, then that means that f is decreasing. So that's what the first derivative tells us. And that's what we get from the first derivative test. If you guys remember the first derivative test, that's that number line test that we did, where you found your critical points. So these would be the critical points. And that's where f prime is 0 or undefined. So at these critical points, that we would test, and I should pick a different color because I'm going to use green if it's ever positive. So these are the critical points, and these are the numbers that make our derivative 0 or is undefined. And then from there we would test it. We would plug it back into the derivative to see if the derivative is positive or it could be negative. And using that first derivative test. So the first derivative test only tells us if f is increasing or decreasing. That's what the first derivative tells us. Now, using that whole idea of increasing and decreasing, well, we can figure out, like if you look right here, our function's increasing and then decreasing, so that would be a maximum. Or if it's decreasing and then increasing, that would be a minimum. So we could use the idea of increasing and decreasing to figure out where a maximum or minimum occurs. So that would come from the first derivative test. All that comes from the first derivative test. Now, what about the second derivative test? So what does the second derivative test tell us? Well, the second derivative, and let me give us a little bit more space. So the second derivative, if it's positive, then what does that tell us? That tells us that the first derivative is increasing. Now think about that. So how do you tell if f prime is increasing? Well, look at its derivative. Just like we looked at here, f is increasing if its derivative is positive. Well, f prime is increasing if its derivative is positive. And if f prime is increasing, then f is concave up. And remember, that's, the smiley face. That would be a concave up, would be a smiley face. And notice concavity doesn't mean increasing or decreasing, because look right here on the left half of this parabola I drew, we have a decreasing function that's concave up, and then it turns into an increasing function that's concave up. And then f double prime, if it's negative, then that tells us that f prime is decreasing, which tells us that f would be concave down. And that's what we use the second derivative test for. So that's really everything we get from f, f prime, and f double prime. And when we do our test, by the way, a point of inflection, it's really similar to a critical point. The difference is that for a critical point, we have that the derivative is 0 or undefined. Automatically, if the derivative is 0 or undefined, that makes it by default a critical point. Point of inflection, we start with where f double prime is 0, but it has to have a change in concavity. Point of inflection is where f has a change in concavity. So we'll start with where f double prime is 0 or undefined. But you need to test. You need to test them to see if there is a change in concavity. Because if the concavity doesn't change at those spots, then it wouldn't be a point of inflection. Unlike the critical points, just by it being 0, just by the first derivative being 0 undefined, it's automatically considered a critical point. So let's go to this graph over here. If we're talking about, if this was just the graph of f, let's just say this is the graph of f, and you want to know where is f increasing or decreasing, we'll just look at the graph. Right here it's increasing because it's going up. Right here it's decreasing because it's going down. Right there it's increasing because it's going up. So just look at the graph. If it's f, it's doing what it's doing, that's what you think it's doing, and that's probably what it's doing. Concavity, concave down, we got our sad face. Concave up, we got our happy face. That's for the graph of f. Now, how would we use this? Let's just change this graph. I'm going to change it to f prime. So what does that tell us about f? So what does this tell us about f? Well, we know if f prime is positive, then f is increasing. I don't like this zeros. There we go. And now I don't like this 0. So if f prime is positive, then f is increasing. Well, when is f prime positive? Well, when it's above the x-axis. Right here is our x-axis. So right here, this interval, you would answer with the x values. On that interval, it's increasing. What's increasing? Not f prime, but f, because f prime is positive. That's your justification. F is increasing because f prime is greater than 0. That's all you have to do to justify. You don't need to over-justify. When's it decreasing? Well, when it's negative down here and right here. And it's increasing once again right there. So where you see the green, it's increasing. The pink, it's decreasing. And then we're talking about f. That's what f prime tells us. So how can we use this to figure out maximum minimum? Well, sometimes it helps to just quickly draw a first derivative test. And you can see it's decreasing and then increasing, then decreasing and then increasing. So you have your minimum, maximum, minimum. You could definitely go through it like that if you want to. That really helps. If you don't, you could just look at the graph and see, okay, because it's decreasing, f is decreasing and then increasing, so right here, this would be a minimum, and you have to kind of picture that, okay, it's negative and then positive, so that's a minimum, positive and then negative, still goes through that same process, so it almost helps just to write out that first derivative test. See if I can erase this. Oops, I didn't talk about concavity yet. You know, I need to erase this anyways, and then we'll talk about concavity. There we go. So how can you tell concavity from f prime? Well, remember down here, f prime is increasing, then f is concave up. So now when is f prime increasing? Because if f prime is increasing, that means our second derivative is positive. Think about that. Take some time. Pause this video and think about that. So if f prime is increasing, then that means f is concave up. Why? Because f double prime is positive. So right here, f prime is increasing, so that tells us f is concave up. Right here, we're decreasing. I should be highlighting this. Right there, we're increasing, so it's concave up. Right there, we're decreasing, so it's concave down. And then we're back to increasing, so f is concave up. I know f prime is increasing here, but that tells us that f, the original function, would be concave up because f prime is increasing there. If they give us the graph of the second derivative, let's just say now that this is same graph, we'll use the same graph. Let's just say this is f double prime. So what does this tell us about f? Well, we really only can get, points of inflection or concavity from this. So it's increasing here, so f is concave up, then decreasing there. So we're concave up here now. Or not increasing, never mind, I already made the mistake. We got to be careful there. So we're looking when f double prime is positive. So that means right here, f double prime is positive right there and there. So that's where f is concave up. And then right here, f double prime is negative there and there. So that's when f is concave down. And from there, your points of inflection would be right there, and right there, because it's changing concavity at those spots. And that pretty much is an overview of f, f prime, and f double prime. Highly recommend that you really just try to get a hold of this, understand this, watch this video till you get it, watch other videos till you get it, read stuff till you get it. But this is definitely going to probably show up on that AP test.